Hello everyone, I am Suraj. Welcome to my YouTube channel. I am a geologist by profession. The purpose of this channel is to share some coding related videos, particularly with respect to geoscience. I also may be sharing some of my small applications which I have developed through this channel. So let's get started. So this video is regarding two Python applications which I have developed to find matching RE minerals from the database of webmineral.com. RE minerals in the sense minerals containing at least one RE element in its composition. So when you have EPMA data of common silicate minerals, what you do is use some Excel sheet or some softwares to do mineral formula recalculation. But for RE minerals, this is not the case. You search for minerals matching your data with websites like webmineral.com. So here in the site, you enter the elemental compositions like lanthanum, cerium, neodymium, and put some tolerance limit and press submit. And you will get some results. So when you open some minerals and check, you will see that there are, apart from the lanthanum, cerium and neodymium, there is also phosphorus, thorium and silicon. So what you do is you refine your search with respect to phosphorus and other minerals, other elements. So here if you enter phosphorus and put some data around 35 and press submit, then you may not get the data. Sometimes you will increase the tolerance limit again, then you press submit, then you will get another list of minerals. So you open each mineral and check whether it is matching with your data or not. So this will take some time. So if you see, for example, some minerals like this site, if you open this and check, you can see there are so many elements in its composition. So if you have EPMA data also like this, like you are having so many elements in your composition, so searching using 3 elements at a time in this website will take a long time. So in order to ease this process, I have developed this application. Actually two applications. One is a web application and another one is a desktop application. So web application I was not able to deploy it online due to its size limitations. Usually there are free web hosting platforms for small applications and static websites. However, I have provided a link of my GitHub repository from where you can clone the repository and use it in your local system. So this is my GitHub repository. So this is a link of the repository for cloning in your local system. So this is for those who are those who are having a little bit understanding with Python and how to set up environments and run locally and clone repositories like that. So those who are not familiar with Python, I will also be providing a Google Drive link from where you can download the desktop application. The code for both these applications I have uploaded in my GitHub repository. So this one is the desktop application. This also you can clone it locally and use it. Those who don't know this, I have provided the Google Drive link for downloading the desktop application. One more thing, this website, you cannot download in data directly, like this data of this elemental composition, so you cannot download. You can only view this in the web page. Data means this data, this oxide data, weight element percentage, oxide data. So what I do is download this data using web scraping methods in Python. So I had downloaded all the 360 RE minerals and saved it as CSV format. So here if you see, this is the data, RE data.csv. So here you can see, if you go to the bottom, there are around 360 minerals. And this is from the RE database, web mineral database. Some minerals are like IMA 2008-024, etc. So these are IMA unapproved minerals, which are not yet approved. So there are only few minerals like that. So you see there are around 360 minerals from the database. So in this application, you can upload your EPMA data as CSV file, and this application will provide you the results. So I will show you the demo CSV file format. Means this here you can enter your data like this. You can enter any number of elements as columns. So elements with no values, you can put it as 0, or you can leave it as blank. Then one more thing is that this should match with that RE database, this elemental formula which is in the header row. So if you see this one in the header row, whatever elemental formula is given, so that should match with the RE database. So whatever it is written here. So there should not be any blank spaces or any special characters. So if there are any blank spaces or special characters, then that elements will be automatically discarded from the results. So make sure to keep the format same. So first I will show you this web application. So this is the code for that. This I have already uploaded in the GitHub repository, which I have shown you earlier. So you clone this repository, then what you do is activate your environment by typing in this command. And then you go to the working directory and copy its path and change your directory path, and you run the script by using this command. So when you run this application, it will give you a link which will open in your web browser. So this is how the application looks. This is the pop-up window showing a demo CSV file format. So close that one and upload your CSV file. So here I am uploading this test CSV file. Then you press submit button and wait for a few seconds. So here you can see your data is shown here, which data you have uploaded. So some 3 columns will be added at the end. So first is the 4 most similar elements, second most similar, and third most similar. You can mostly go with the most similar elements. But if your data contains minerals like at IMA unapproved minerals like IMA 2008 like that, so in that case you can use the second most or third most similar like that. And if you want to compare with the database of that web mineral database, so you can simply click any one row. So it will display the composition of the similar minerals from web mineral database. So this is for the point 1. So similarly, you can compare it with compare minerals of the other rows also. Like if you click this row, so it will show the results of the corresponding row. Then you can download, and it will be downloaded to your working directory. So my directory is around in this folder. So here if you see in API folder, here it will get downloaded. So if you press download, so you got the result here. You can open and see your result. So this is the web application, and now let me show you this desktop application. So we'll close this one. The desktop application I already have it in my system. So here if you see, this is the folder I have extracted. So from the Google Drive link you will download this application and extract the file, then you will get this folder like this. So in that folder you will see the database, that RE data.csv database. So you have to make sure that no files are moved or modified from this folder, but you can copy these files anywhere. So if you move or modify any of the files, then the application may break. So let me show this application. This is the exe file. You double click the file, then it will open a window. The first window will be showing this demo CSV file format. So make sure your format is correct. Then you click to upload your CSV. Then I will upload that as CSV again and press submit. Here you can see your uploaded data along with that 3 columns. This columns here you can press any row to compare with the web mineral database for that corresponding row. And then you can also check for another row. Then you can download this one. Click to download and select your location where you are going to save this one. That's all. This is the desktop application. And now coming to the theory part of how this works. For that one also I have prepared a Python script, which will demonstrate the theory part. So I will show you that one. First let me close this folder and open the folder where I am having that Python script to demonstrate that theory. Let me activate the environment. Now there is a mathematical concept called cosine similarity in vector algebra. You might have studied in school days. So you can check in the Wikipedia about the formulas. I will show you how that works here. Actually, that formula is dot product of 2 vectors by the magnitude of 2 vectors. So this will give some quantity to see whether your vectors are similar or not. So here in this thing you can see you have some 3 vectors A, B and C. These are 3-dimensional vectors. And if I run the script, you can see there are 3 vectors A, B, C. If you see this one visually, this A and B are close to each other. That is, they are similar almost. And C is a little bit far away from these 2 vectors. So this is dissimilar to A and B. So how will quantify this one similarity? So if you plot the cosine similarity and see, so here if I go to script and uncomment this line, and you can see the cosine similarity calculated. If I run the script again, you can see this cosine similarity of A and B is the greatest. That is the most similar. And this concept is used to search for your REE minerals. So what this does is you convert the REE database into vectors, and also your user data also will be converted into vectors, and then this cosine similarity operation will be performed, and this will give the most similar minerals. So this if you see this once again, if you see this one, if I modify some vectors, for example, if I make this vector C almost diagonally opposite to vector A by changing the signs, like A is 1, 2, 6 and C is -1, -2 and -6. So if you run this application, you can see here now vector C is almost diametrically opposite to vector A. So now you see that cosine similarity of A and C is -1. So if any vectors are opposite to each other, then the cosine similarity will be -1, and if it is along the same direction, then the cosine similarity will be 1, and if it is opposite to each other, then orthogonal to each other, then it will be 0. This is how this works. So if you want to find the orthogonal vector to vector A, so I think this is the orthogonal vector, like -6, 0, 1. So let me again run the script. So now you see, now A and C is orthogonal. So now you see the cosine similarity is 0. And if you see, if I can multiply this vector C with 2, then it will increase the length of C to twice its length to C. Then also the cosine similarity will be 0, because cosine similarity does not depend on the magnitude, it really depends on the direction. So this is the concept which is used in this application. So here, for this calculations, cosine similarity calculations, I was used this scikit machine learning library, which is available in Python. Web application was developed using like PyWeb.io, and the desktop application was developed using PyQt library. So hope this helps, and thank you, and see you again in another video.